Okay, and we're back. Let's just share on social media. Well, basically it's Twitter and LinkedIn. So that's pretty much it. Now Twitter. And there we go. Okay. Well, okay, where were we? Break, continue, pass. Okay.
Welcome back. Now, up until now, we saw the break keyword that we can use to break out of a loop. And you see here that we're able to loop with a for loop, but with a while loop, as soon as we break, we're done. We've just, well, broken out of the loop. But could we do that in a for loop? Let's find out. Yep, break keyword works in a for loop as well. But there's actually two other things that we can use besides break. One is called continue. And you can see here, again, blue highlighting. If I do continue here, and I click run, there you go, we get our looping again. But you're thinking, why do we need this? Like, it seems completely useless, right? Well, a break, when we use the break statement, it breaks out of the current enclosing loop. So when we used a break statement, we broke out of this loop, right? This whole while loop, we just exited it. And same with the for loop, we completely exited it. However, with a continue, what we're saying is, hey, whatever happens when you hit this line, continue onto the top of the enclosing loop. So the current enclosing loop, what is it? It's this for loop. So it's going to go back to the for loop. So that if I do something like print here, so that we get it printed twice, or you know what, let's just move print down here, like that. And then same here, we're going to just print at the bottom after continue. If I click run, nothing gets printed, because as soon as it sees continue, it's going to say, okay, I'm going to go back to the loop. And it's going to keep going until, well, the loop ends, so that we never actually hit line 10 and line 4. So that becomes really useful in conditional logic as well. Finally, the third one is called pass. And pass is, well, not very useful. It essentially does nothing. If I click run here, and again, it shows me here, line 10, something's wrong. Well, we have to move print up to the top so that, well, we don't get my list of index of 3, which doesn't exist. So again, going back here, if I click run, pass doesn't do absolutely anything. It just essentially passes to the next line. So why is that ever useful? It's very rare that you'll see pass in your code, but pass is a good way to have, let's say, a placeholder while you're coding. For example, you want to loop through the for loop, but we don't know what we want to do yet in the code. Let's say that here we're still thinking about it. If I do this and I click run, I get an error here because, whoa. Expected and indented block, because now the for loop or the Python interpreter is looking for the next, like, what am I supposed to do with the loop? I'm trying to loop and there's no code for me. So you can add a pass here to at least fill something for the for loop to say, hey, I'm thinking about it. I'm just going to pass it for now just so you have something so you don't bug me, and I'll come back to it. So if I click run, that still works. So pass is one of those placeholders that we can use so that there is a line of code that does absolutely nothing that we can still pass through. Again, a very rare thing to see in production code, but while you're developing, some developers like using pass. And there you have it. Break, continue, and pass. I'll see you in the next one. Bye-bye.
Wait a minute. Well, he's explaining the use on this case, but I wonder what does pass actually do, because continue breaks the loop, the current iteration, and goes to the next. Break breaks out of the loop entirely. What does pass mean?
So again, going back here, if I click run, it's called pass. And pass is, well, not very useful. It essentially does nothing. If I click run here, and again, it shows me here, line 10, something's wrong. Well, we have to move print up to the top so that, well, we don't get my list of index of 3, which doesn't exist. So again, going back here, if I click run.
Wait.
So again, going back here, if I click run, which doesn't exist.
What? What I'm losing video? Is something wrong? Oh, wait. Okay, I'm fixing HDMI cables. I do have a little mesh behind my desk, but never mind. Okay, so pass doesn't do anything. Then why does it exist? Because I need it as a placeholder for the loop.
So again, going back here, if I click
I don't know. Something. Okay, the pass statement, thank you. Okay, what does it do? In Python programming, the pass statement is a null statement. The difference between a comment and a pass statement in Python is that while the interpreter ignores a comment entirely, pass is not ignored. However, nothing happens when the pass is executed. It results in no operation, NOP. Oh, syntax of pass. We usually use it as a placeholder. I suppose we have a loop for a function that is not implemented yet, but we want to implement it in the future. They cannot have an empty body. The interpreter will give an error. So we use the pass statement to construct a body that does nothing. Okay. Okay, so pretty much it works as he described. Okay.
Run. Pass doesn't do absolutely. So you can add a pass here to at least fill something for the for loop to say, hey, I'm thinking about it. I'm just going to pass it for now just so you have something so you don't bug me. And I'll come back to it. So if I click run, that still works. So pass is one of those placeholders that we can use so that there is a line of code that does absolutely nothing that we can still pass through. Again, a very rare thing to see in production code, but while you're developing, some developers like using pass. And there you have it. Break, continue, and pass. I'll see you in the next one. Bye. All right. Your head must be spinning because of all these looping. That's a really bad joke, but I thought it was funny because I've been recording for hours now and I think I'm going a little kooky. So this is going to be my last video for the day, not for the course, but we're going to do a little fun exercise. Now I call all exercises fun. Obviously I'm biased, but this one's especially fun. What are we going to do? Well, we're going to simulate what a computer does when we have something like a graphical user interface. That is, a computer is able to display, let's say, even an image over here, right? I can see the robot over here. I can see the mouse. This is a graphical user interface. I see pictures, I see images on my screen, pixels on my screen, and I can control them. Well, we're going to create a basic version of this to show you how a computer would work just from the stuff that we've learned up until now, using loops and using conditional logic. So what are we going to do?
Oh, no.
This is the exercise. And you can check out the REPL here, or you can recreate this, or again, in this video, you should have resources attached that you can play with it yourself. And what I want you to do is I want you to loop through this list of lists, and every time you encounter a 0, I want you to display on the screen over here an empty space. Because a 0 in a computer denotes nothing, right? We want a blank on the screen. However, when I see a 1, I want to simulate a pixel, right? That tiny, tiny dot on our computers that can be full of colors. It can be green, it can be blue, it can be orange. But for our case, I want it to be a star. And using that, I want you to create a program that takes this picture that, let's say, is in our database or in our computer's hard drive and displays it on the screen using space or multiply. And all I want you to do is when I click run, I want you to display that image right here. All right, this is a little tough one, and I'm kind of letting you figure out on your own. But trust me, you've learned all the tools necessary to do this. Pause the video, give it a go. Otherwise.
Okay. Well, I guess that considering that we were looking at loops recently, I guess he is expecting me to write a loop. Let's do it here. So I wonder if I can just copy there we go. Okay, exercise in REPL. Oh, please load, come on. Okay. What's this? Show files, I guess. Thank you. Just going to copy that. What? It's not pasting. I don't know why. Doesn't do anything. Okay, so here's the picture. And as we can see here, I do have a list that contains several other lists inside. So I guess that, okay, for pixel, let's just call it like that, and in picture. Okay, so what I'm doing here is that, well, actually it's not a pixel, it's more like a line for, yeah, on the picture. Okay, and now that I'm going through every single iteration of that loop is going to be an entire list, another list, so this list over here. Okay, on the next run of the iteration, I'm going to get this line over here and so forth. So once I get a line number 1 is going to be this one here. So this list is an iterable object anyway. So I can nest of another for loop, and I'm going to call this the actual pixel in line. And let's remember that this variable line is all of this, just one. Okay, for pixel in line, you're going to do this. Okay, what am I going to do? Well, if pixel is equals to, I can actually do a ternary here. Ternary, I don't remember how to do it. Python, ternary operator Python, thank you. Let's see the syntax. Oh, come on. No, oh my God. Okay, ternary operator. There we go. Syntax. Condition A, Boolean expression to either true or false. True val. Oh, wait, what? True val if condition else val. Okay. Let's copy this bit here. Well, actually, this makes sense. But anyway, let's work around here. So what I want to do is evaluate pixel, and if pixel is 1, I'm going to print an asterisk. If pixel is 0 or something else, I'm going to print a space, basically. So the idea is to return the character itself. So if the condition is true, what value am I going to print? In my case, it will be an asterisk. What's going to be, if it's false, I may like to print a white space. And what's the condition? Well, the condition is going to be if pixel, thank you, if pixel is equals to 1, then print, actually it's not supposed to be read that way. It's supposed to be asterisk if pixel is equals to 1, else white space. Yeah, that reads way better. Now I understand why they order it this way, but anyway. But this is an expression that is not going to do anything. It's just going to evaluate, do its thing, it's going to return the value. But since I don't have a print statement, it's not going to show anything. So what I'm going to do here is enclose all of this in a print function. And that should do it, I guess, I hope. Okay, so, well, I got something, but not what I was expecting. So let's see. Okay, I got 1. And let's see, I am doing something wrong because the idea is going to be printing spaces. Let's change the character to something else. There, it's the same. Okay. Okay, so let's see. So basically, I'm getting the first time here, I'm going to print 1, 0. I mean 0. This is 1, 2, 3. Okay, so I'm going to get. I wonder why. Ah, yeah, because they are different print statements, and every single time I do a print, it's doing it. I get it. So every single print is going to be in a new line. I wonder if there is a way that I can just, I guess I may replace on the list and then print the line entirely. But I don't think that's what he's expecting. Let's think about it. I wonder if there is a print statement that allows me to, maybe I just need to concatenate a string. That may be a way, or make a print. Yeah, that's actually what I can do here. Let's try that. Let's see, for example. Okay, line, I guess. What I could do is create a string, and at the end of the inner for loop, at the end of this loop, I will print the entire line, for example. Okay, that's that. Well, there is a print line. You are going to be equals. This is going to be the string. So what I may like to know is what do I need to concatenate all of this there. See, I created this new variable called print line, and I'm going to store there either an asterisk or a pixel or a blank space. But with every single thread, I guess I can do this. What's the name for this again? I don't remember. But anyway. Yeah, I cannot do that. Okay, never mind. I wonder how can I concatenate. Okay. I know how. It must be a concat method, probably. Yeah, let's find out. How to concatenate strings? It's with the plus. Okay. Oh, the video is going out again. What's going on? It's annoying. I believe that the HDMI splitter I'm using here is making some issues here, but never mind. Okay, it must be a concatenation of strings. It's basically just this one here. Okay, so maybe it's not this. Let's copy this. I wonder if I can do that. Okay, because in the end I am returning. Oh wait, but not with this. There we go. Can I do this? Well, I don't need this thing here. It's not needed. I basically just want to concatenate either an asterisk or this. All of this is an error. Why? Undefined name print line. Do I need to define you? Well, I might. Like here, for example, like this. And now I define, actually, this is the perfect place for me to put it, because that means that it's going to restart the print line variable for every single inner iteration anyway. So what's going to happen here is I'm going to pull out one of the lists inside the picture list, and that's going to be a line. So I'm going to initialize this one here, and just an empty string is going to be enough. So Python is going to know that this is a string. And now I run the inner loop, and the only thing I'm going to do is to concatenate either whatever this returns. Basically, I'm going to concatenate either an asterisk or a white space, depending on the value of the pixel value. So that's the idea. And when this finishes, and before going up for the next iteration on the picture list, what I may like to do is to print the line. Print the print line. Okay, I think that should do it. And it didn't do it. Now let's see why. I see a lot of white space. Maybe I should test it out with a dash just to see what's going on. Okay, nothing. That's weird. Okay, so maybe this is the reason. Maybe this was not such a good idea. Okay, the next it, oh wait, it's going to enter here. It's going to loop through here. It's going to concatenate either space, and it's when this finishes, I'm ordering it to print a line. Okay, maybe I can test out. No. What? Yeah, let's see. Thank you. I want to print something here just to make sure that, and probably see what's going on. There we go. So I'm getting white lines over here. Okay, I'm printing out the lines, but the inner is not actually doing something. I wonder if I print the actual value, let's take out this and print it here. There we go. Okay, so it's actually iterating something here, but it's not giving me, it's just printing that, but the actual variable remains the same. Okay, let's see. So my idea is, or was, let's remove this from here for a while. There we go. Okay, it does the same. I wonder if this line is actually concatenating something. Maybe I just need to print out. My idea was to just print out this here. Actually, why I not doing that already? Oh, I just need to travel across the entire thing and just print this one. I just need to print. I don't really need to store the values anywhere else. And that should do it, basically. Ah, but I came back to the same issue I had. I wonder if there is another kind of print that doesn't jump to the next. Yeah, that's what I need. Okay. Print Python. No end of line, something like that. Print without new line. Thank you. Okay, to print without a new line in Python 3, add an extra argument to your print function telling the Here is an example. Print hello there. Okay. Hello there, comma or colon. And is this right? Ah, okay, I can change the end. N equals and whatever I want. Perfect. Okay, I get it. Oh my god, these fonts are really awful. I'm going to type it myself, never mind. So I guess that I wonder if this is going to work here. Okay, let's try this. And n equals to empty string. I hope this works. Okay, we're getting somewhere, but now it's printing everything on the same line. And that's not what I want. Okay, what I need to do is to add a single new line whenever this finishes. So on the next line, I'm going to go back one indentation level, and I'm going to print an empty string. I'm going to print an empty string, and that's it. That's going to create no new characters on the screen, and it's going to create a new line. Okay, there we go. We're getting somewhere, and now I only need to replace this with a white space. And we have our picture here, and it's a very beautiful tree. I learned a lot here. I learned about this, that I can remove the new line at the end of the print statement. And okay, that's it, I guess. Okay, I guess that this is not the same answer that he's going to come up.
Show you how it's done. So
Let's
the very
see
first thing
how
I'd like
it's
to do
done.
is to think about what I'm about to do.
Okay.
I want to make sure that we have a plan in mind. So I'm going to comment first. And I'm going to say, well, we definitely want to iterate over a picture.
Hello, hello, hello.
Right?
Okay.
So we're going to do some sort of iteration here. So that's number one. And then in here, I want to say that if it's a 0, then I want to print an empty space. And if it's a 1, I want to print a star. All right, so that's the plan. Okay, so this shouldn't be too hard. Actually, before you get started, in order for this to work, you need to Google a special parameter or special option that you can give the print function. And as a matter of fact, the print function that you need to add, or the option that you need to add, is this end option.
Oh
If
my
we scroll down, it doesn't
god.
display it that well, but you can see here, string appended after the last value. So the default when we print something is a new line, but ideally we might not want a new line. So when that happens, you might have to use this end option. Now, I know I left it really vague. I want you to practice Googling this and figuring out from your mistake. You're going to have a bug when you create this code, when you try to display this information. But try to solve it using the tools that you have of problem solving. All right, enough talk. Let's get to it. So the first thing I want to do is iterate over the picture. I'm going to say for...
Wow, are we going to end up with the
picture
same
as well.
answer?
This is one picture
No.
right here. So this is the picture, but it's inside of a list because we can have multiple pictures. And then I'm going to loop once again over this individual list. So once again, I need to do a for loop. And this time I'm going to say for pixel because each one of this is a pixel in the image. So this is a nested for loop. Now I'm going to add a conditional and say if pixel equals 1, then I'm going to print a star. Otherwise, I'm going to print an empty string. Well, maybe not empty, right? Because we do want a space, a blank space.
Yeah.
All right, so let's see if this works. If I click run,
That's
not
my
really what I
first issue.
I want a clear image here, but I'm just getting things one in line. And remember, this was the little trick where a print, every time it prints, it creates a new
A
line.
new line.
The
Yeah.
default, again, if we close this, you'll see is that end equals to this escape sequence of new
By
line.
default.
So we can change
Oh,
that
that's
by
the
simply saying
default.
star, comma, end, and then I'm going to say for the end, I don't want a new line. I just want, well, a string, but an empty string.
An empty
And
string.
same over here, if I do comma, end, and if I click run, all right, it's getting a little bit better, but now I have an issue where we don't have any new lines. Everything is on one line. That's not good. How can we solve this? Well, ideally, at the end of this first loop, where we're just going the image or the line in the image, at the end of this, we create a new line right here, right? So again, looking at the indentation, I don't want a new line on every pixel, which we had the first time, but I also want to add a line between the lists of rows. So maybe a better name for this will be a row in picture. And in here, I'm going to add at the end of this for loop, so after we're done looping through the entire row, at the bottom here, I'm going to print an empty line. But remember, the default is going to be a new line. So again, an empty string is going to default to a new line, and we're still going to have this code. If I run this, oh, I get an error because image is not defined because I've just changed it. to a row. So let's do row here.
Row.
Click run. And look
Yeah,
at that.
put
We have our
line.
beautiful Christmas tree. If you don't think this is beautiful, this is the best I could. But this is a Christmas tree. And we finally have it displayed.
Okay.
We've used loops, we've used conditional logic, and we used a little Googling to figure out, hey, we need this option. Now, our code works, but I want to do something better here. And in the next video, I want to clean up this code a little bit and cover a very important topic when it comes to programming. I'll see you now. Bye-bye. It's happening, our next developer fundamentals, and that is, what is good code? I mean, what is good? That seems so vague, right?
I don't
Somebody
know,
says,
bro.
I'm a good coder, I'm an excellent programmer. He's a senior programmer, he's an expert programmer, he's a tech lead, he's a genius. What does that really mean? Well, you can narrow it down to these simple statements. What is clean, good code? I kind of gave it away. The first one is clean. That is, we want to make sure our code is following a style that, let's say, the Python community endorses. Are we following the best practices? And Python has this great feature of auto format. And Python has standard ways of using spaces to make sure that our code is clean. I'm not using unnecessarily ugly spaces like this, or maybe making lists really weird and funky, maybe no spaces in between here. Maybe I have a lot of random comments over here.
Yeah, no.
Keeping our code clean. We make sure that every line that we have is easily readable, but also we don't have any extra stuff that...
Yeah, no extra stuff.
And this also relates to the idea of readability. Now, readability means the ability to read your own code. Maybe 2 years down the road, you're going to come back and look at the code. Are you going to be able to understand it? If you work in teams or for companies and other coworkers come and look at your code, is it easy to understand? And here, this is obviously personal preference, but most of the time the ideas are simple. For example, I'm using names here that make sense. If row don't make sense, it'll be really hard for somebody to read my code. Maybe people will be confused why I have this print statement here. In that case, maybe I should comment in here being like, need a new line after every row. Or maybe they'll be confused why we need this as well. So depending on your style, you might want to add comments, make sure that the naming of your variables are good, and maybe making sure that it's not only you that understands the code. The other one is the idea of predictability. And this is my favorite one. That is, sometimes people try to be really clever with their code, trying to have the most compact code, or using the newest features or some really obscure tools or functions that are not very common just to look, well, frankly, smart.
Yeah.
But you want to have code that makes sense, that does things, just one thing really well. Now, this code is quite small, so it's quite predictable. You know, it just has one pass-through, and it's easy to predict what's going to happen. We're going to print. But as we get more and more into the course, you'll see that our code is going to get larger and larger. And having predictable, easy-to-understand code is really important.
Yeah, it's really important.
Finally, this is an important principle that you'll hear everywhere, is DRY. Do not repeat yourself. You don't want to have code that you're constantly repeating yourself over and over.
Yeah.
Again, this is a small example, but it's very easy as a programmer to say, oh, I'm going to copy this, and then I'm going to run this again so that if I click run, look at that.
I get to.
This is amazing. But maybe that's not the best idea. You now have 28 lines of code.
Yeah.
People might be confused why we're doing this twice. Maybe instead, we want to programmatically have a counter here.
Yeah.
Maybe saying running this twice, or maybe using something like functions, which we'll learn later, to make sure that we can repeat this process over and over and over.
Yeah, a function.
Now, keep these in the back of your mind because
Or
we're
a
going to
method.
explore these topics. But
Or a
let's say I
class
just came
method.
onto this code,
Class
and I wanted
function?
to clean it up a bit. Again, this is just personal preference, but these are some of the things that I would do. One is here, pixels equal to 1. Instead, this is kind of confusing. I'm just going to say if there's a pixel here, and I know that pixels are either 0 and 1, then print here, because this is a truthy value that will just evaluate to true. So that just kind of cleaned up my code a little bit better. Next, another thing that I might do, maybe I want to make this more extensible, which might mean doing something like, let's say, fill variable that equals to the star, and then maybe empty, which equals to an empty string, and change these to fill and empty. Now, this is extra line of code, but for example, if we're doing this multiple times, instead of perhaps maybe we're running print over and over and over, or maybe we have another line of print over here, and another line of print over here, and then maybe another line of print over here that is empty. Instead of me having to change 5 locations here, I can now change just this one. Maybe instead of star, display, I don't know, $sign. And if I run this, all right, I get a little different image here, but again, I was able to just change the variable, and the variable was used to fill out whatever I needed done. Now, these are all things that you do need a bit of experience to get used to, but we'll hopefully explore this throughout the course, and by the end of it, you'll have all these best practices in mind. I'll see you in the next one.
Yeah, that's called refactoring. Refactor, basically.
Welcome back. Let's do an exercise
Well,
to check
one of
duplicates
the
in list.
refactors
So
available.
I have some lists here, and I want you to be able to check this list and
Find
print whatever
duplicates.
the duplicate values are.
Okay.
In this case, we see that N has duplicates, and also B has duplicates. So I want you to print B and D as a list in here. How to go
Okay.
about doing that?
There is a
Pause the video,
method?
give it a go. Otherwise, I'm going to keep going with the answer.
Okay. I believe there is a method for sets. No. No, that's a solution, bro. Are you going to make me type that? I no longer need you. Yeah, that's the answer, but let's try not to read. Okay, I didn't see anything. Okay. Please tell me I just copied that one. There we go. Whew. Okay, so unless he wants to print the duplicates. Okay, so A, B, C, B is one, and N is the second. Okay. So how do we do that? I think there is a method for Python list. There we go. Okay. Let's check it out. Clear copy count. Oh, nice. Okay. Well, there is something useful here. It's called count. Returns the number of elements with the specified value. What I could do is use a for loop and call this function here, or well, this method actually, and see how if the count is greater than 1, then print that element. That's what I'm going to do. Okay, so let's see. Let's try first. Some list, thank you. Dot count, and let's try for A. This is just a test. So this is what I'm going to do. I want to print the count of A. There is 1. Let's try for B. There is 2. Okay, so the idea is I'm going to be doing this in a loop. So I'm going to enclose this in a for loop. And let's say letter in some list. Thank you. Semicolon. And this is the body. And I want to print this conditionally. So I wonder if I can do this in a ternary. Okay. Let's try something here. Instead of the letter B hard-coded, I'm going to type letter. Okay, some list count letter. That's going to be part of the condition. So what I want is to print letter. If I want to print letter, if actually I think I can do this. Print. I can do a statement right here. Print letter if the count of letter is greater than 1. Okay? If it doesn't find anything, don't do anything. If it's greater than 1, print something. Else, pass, I guess. That's the ternary. Oh, I forgot. I already forgot about the ternary operator. Wow. Okay. Else, no, that's just fine. Okay. Go away. Let's see what did I did something wrong here. Okay, else. So I cannot use it here. It's what's going on? Pie flakes, invalid syntax. Can I remove the else? Damn it, no. Yeah, okay. Okay, else. Okay, print letter if some list.count. Oh, wait. Okay, so it's 1. Don't print anything. Or else. Well, actually it's going to be letter plus a comma and a space. So it makes some sense. Okay, unless it's the first one, so it's not going to make too much sense anyway. I don't want to print anything. Ain't we supposed to? Okay, true, I guess. Is that valid? Thank you. So it's going to return true. I want it to be pass. Why not? Earth pass. Why cannot? Well, I can actually then say, you know what? Just continue. Either, okay. Oh, or I might print out the comma. You know. Well, something like that. I don't know. If not, well, no, not really. Maybe a white space. Okay, let's keep that back. Maybe print a white space. Can I do this actually? I don't know. Let's try to return true because it's not going to do anything with the value anyway. Okay, that doesn't sound too good. Oh yeah, because it's printing B twice. Okay. Yeah, it's going to become a little bit complicated here now. Because now I got myself into the issue of, okay, maybe I could create a new variable to host the result, for example. Result, like this, for example. And what I want is result to have these values just once. So, okay, let's say if the count is bigger, okay, add it to the, yeah, because it's going to add it, it's going to print it twice. And I already printed that, so maybe result concatenated with letter, and it's going to basically add the same letter over and over again the second time. Wait, is there a way to find duplicates directly into, yeah, what happens? Can I find duplicates? Wait, because I may find the actual answer. So to the end of the list, removes all elements, returns a copy of the list, count the number of elements, specify value, add elements, index, returns the index, adds an element to specify position, pop, remove, reverse, sorts. What can I do? Okay, what can I do? Well, I can ask if the element exists already on the result. Okay. Copy, count, index, returns the index of the first element with the specified value. Let's see what happens if it doesn't find anything. Okay. Only returns the first occurrence of the value. Let's try it out. Index of 32. Let's try a number that doesn't exist. Okay, it's not on the list and it's an error. Okay, so that may not be the best way. Well, I may ask if I already inserted it on the result. And if I already inserted it into the result, then do nothing. Okay, else true, I guess. I guess it's going to require a more complex, a complex if statement. So let's do this. I'm going to make it a full if statement. If, and then the condition. Okay, I'm going to ask, okay, is this letter repeating more than once? If so, I want to add it to the result. Result, and I'm going to concatenate the letter, and I'm going to concatenate, well, result is going to be equals to result, whatever result is already, plus the letter, and well, it's the first one. Anyway. Okay. And maybe like this. Maybe a comma. Okay. It's going to look weird if that is just the first one. But anyway. Okay, so what else? I'm going to ask else elif. If that's not the case, well, that's it. I don't need anything else. Okay. Yeah, that's pretty much it. I'm going to ask if the letter appears more than once. Then I'm going to concatenate the value of the letter itself and a comma at the end. Okay, I don't think this works. Why it doesn't work? How do I concatenate this? Okay, well, I might only... Well, it's going to actually print twice the value. So after this happens, I need to ask if... Oh, wait, I can make this an array. Well, a list. There we go. And I may use the methods to actually, let's see. Let's keep that one there. I want to ask if the letter appears more than once, I need to filter out that it's not already inserted into the result. So I'm going to ask pretty much the same thing. There we go. I'm going to ask, you know what? If the result count letter is greater than 0, that means that I already inserted that one here. Okay. I can just reverse all of this, I think, I hope. Okay, this is going to be like this. There we go. Can I do this? Okay. Can I delete this? Okay, I can keep it cleaner. Okay. I'm going to ask if the letter is not already inside result. If the letter is not inside result already, then I'm going to insert it. So I'm going to say result dot add. Is add? What's the name of the method? Listen, there's no. Append to the end of the list. Thank you. It's append. Letter concatenated with a comma and a space. Okay. And that's pretty much it. At the end, I may like to print the result. Let's see if that works. There we go. Okay, we're getting somewhere. Oh, well, actually, I don't need this because I already have a natural separator here. So if I do this, there we go. And that's it, I guess. That's yeah, that's the result. What does this mean? Oh, okay. Let's see what was the answer.
By the way, you're not allowed to use sets for this. So for this exercise, you can't use the data structure sets. Instead, you have to just use conditionals and loops that we've learned in the past.
Okay.
So give it a try, pause the video, and when you're ready, I'm going to go ahead with the answer.
Yeah, because if you create a set and assign the list, you are only going to get the only the unique values, basically. So when you create the set, although you are creating although you have several instances of B and N on this case, it doesn't matter. You are just going to have one, but that's just halfway. You may need to. They are asking you to print out only the difference there. So I will ask, you know what? Print out the difference between some list and the set, and that's it. That's with 2 lines you can do this. But yeah, I get it.
First, I'm going to create a variable called duplicates, and this is going to be an empty list that we're going to populate with any duplicate values. Next, I'm going to loop over this list, so I'm going to say for value in some list. And in here, well, what can we do? This is a tough one, but what I'm going to do is say if some list dot count. Remember, count allows us to count how many times an item in a list exists.
Yeah.
I'm going to say value, so that some list dot count, and I give it A. It's going to count for me how many times A happens in the list. Very, very useful. Again, if you didn't come up with that, there's many solutions to this problem, so there's no one right answer. I'm just showing you how I would have done it. Now here, I'm going to say if that's greater than 1, in that case, that means there's a duplicate. So I'm going to add it inside of the duplicates. So let's just go ahead and say dot append, because I want to append, and in here say value. And at the end of all this, let's just print duplicates. Now let's see if this works. I'm going to click run. And all right, I get both B and N.
Yeah.
I don't need this duplicates. I just need to know what are the duplicates. I just need one instance of B and one instance of N. So what we can do here is do another if statement.
Another
and say if value is not in duplicates. And yes, this is a bit of a trick. You may remember that not is the opposite, right? So we're checking, hey, is value
Actually,
in
I forgot about the N.
Essentially says, hey, if value is not in duplicates.
Yeah, he's right.
And this is going to evaluate to true.
I'm making the computer do extra work. If yeah, I'm making it do extra work here. If result if letter not in result, that's it. The same result, but I'm not making the computer do extra work. Yeah, he's right.
And then finally, make sure that we get the indentation right. We're going to append the value. So if I click run, I get B and N. Again, if you didn't get this right away, don't worry. It can get tricky, and this is one of those things that you just need to keep practicing. But you see here that I was able to use loops, I was able to use logical operators like not, and conditionals like if statements to solve a problem in just a few lines of code. It's time to talk about functions. This is where things get really interesting. Because up until now, we've seen functions, right? Functions were things like print, like list, boolean. We even saw the input function to get the input of whatever the user types. And those allowed us to perform actions on our data types. But the true power comes when we can start creating our own functions. That's right, we're not limited to whatever Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. The way we create a function in Python, and functions, by the way, exist in all programming languages. They're very, very important. If we do def, that lets the Python interpreter know that we're about to define a function. Def is short for define. So the interpreter is going to say, all right, they're about to define a function. What's the function going to be? Well, we can create whatever we want. We use the same naming case as we do with variables to define our functions. So let's create a function. Again, we'll call it, say, hello. Just a variable that I created, but this time it's a function because we use the def keyword. Now in here, in say hello, we also add the brackets to let the interpreter know that this is something that we're going to take action on, or this is going to perform an action on a data type.
What time is it? Wow, 6:40 p.m. Central Standard Time. Okay.
We use the colon, and then within this block of code, we can say print hello. And that is a function. If I click run, nothing happened. Why is that? Well, we've created the say hello function.
Wait, what?
Living somewhere in memory on our machine. However, in order to use a function, remember,
excuse me,
lets the Python interpreter know that we're about to define a function.
We are
functions.
Watching functions really already, okay?
Because up until now, we've seen functions, right?
Yeah.
Functions were things like print, like list, boolean. We even saw the input function to get the input of whatever the user types. And those allowed us to perform actions on our data types. But the true power comes when we can start creating our own functions. That's right, we're not limited to whatever Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. the way we create a function in Python, and functions, by the way, exist in all programming languages. They're very, very important. If we do def, that lets the Python interpreter know that we're about to define a function. Def is short for define. So the interpreter is going to say, all right, they're about to define a function. What's the function going to be? Well, we can create whatever we want. We use the same naming case as we do with variables to define our functions. So let's create a function. Again, we'll call it, say, hello. Just a variable that I created, but this time it's a function because we use the def keyword. Now in here, in say hello, we also add the brackets to let the interpreter know that this is something that we're going to take action on, or this is going to perform an action on a data type. We use the colon, and then within this block of code, we can say print hello. And that is a function. If I click run,
it's not doing anything. You need to call it. Yeah.
Why is that? Well, we've created the say hello function. We've defined it, and now it's living somewhere in memory on our machine.
Yeah,
However,
but it's
in
not.
order to use a function, remember, just like we use the print function, we have to call it with the brackets. So after we define a function, we say
hello.
And did you notice how my REPL, as soon as I said say, actually gives me the say hello command?
The function.
Which shows that it's a function. Well, we now have it available for us to use. Just like we have the print function available for us to use. So if I do say hello and run it with the brackets, and I click run, I get hello. How cool is that? By the way, what happens if I run it without the brackets and I click run? Nothing happens. Because remember, in order for us to take an action, we have to let the interpreter know, hey, I want to run say hello. Now, the reason functions are so powerful is because of the principle that we've talked about, right? The idea of DRY, which stands for do not repeat yourself. Functions are really useful when you have things that you want to do over and over.
Call it.
For example, the print function, we've used it a lot.
What about the arguments?
Every single time, and say what print function does. Luckily, Python gives us print because it's such a useful tool. But if in our program, we want to say hello multiple times, and you can imagine this actually being a lot more complicated, maybe 10 lines of code. Instead of writing those 10 lines of code over and over, I can just define it as a function and use it anywhere I want in my program. For example, remember this, where we have a picture, and we printed a Christmas tree?
Yeah.
Imagine if we wanted to run this multiple times. In order to do that, I would copy and paste this code.
Yeah, inside the function.
And I click run. I now have 2 Christmas trees. But look at that, 26 lines of code. I just copy and paste the same thing over and over. With a function, we can do something like this. I can say define show tree colon, and we now have a function. But remember the indentation in Python, right? And indentation. Colon, we're defining a function, so we have to create that code block inside, saying, hey, whatever's indented here, that's part of this function. So now that we have the show tree, check this out. I can say
show tree twice.
Maybe let's run it 3 times.
Yeah, 3 times.
If I click run,
it's cleaner.
How is that? I'm able to do the same thing over and over.
That's just halfway to.
And that's the power of functions. Functions allow us to keep our code dry, we don't repeat ourselves, and reuse things that our machines can do over and over. And the beauty is that this stays in memory for us. Show tree now means something to this program because we've created it. So we have our own custom action that we can take. Now, what happens if I move show tree here to the top? Well, if I run this, I'll get an error. Name show tree is not defined.
Because at the time...
because our interpreter goes line by line.
Yeah.
It first says, all right, picture equals to this value. And then it goes to line 11 and
show
says,
tree.
Show tree.
But
so
where is show tree?
Yet. So the Python interpreter is going to error out and say, hey, I have no idea what show tree is. What are you talking about? Instead, with a function, we need to make sure that we define the functions at the beginning so that Python interpreter says, all right, show tree now means this. I'm not going to run it. I'm not going to use it yet. I'm just going to keep it in memory. And when I finally come across show tree, I'll know that it means something. I'm going to grab it from memory using show tree, and then I'm going to run it using the brackets. For example, if I do print show tree without anything, without the brackets, if I click run, you see that I get function show tree at this location. This is just a location in memory. This is the bookshelf where we store that show tree function. Very, very cool.
Print show
functions are an important, powerful concept in programming. And in the next video, we're going to extend this and explore this a little bit more. I'll see you in the next one.
Okay. Parameters and arguments. Okay.
Let's talk about arguments versus parameters.
Thank you.
Which is one of our key terms that we use when describing functions. Let's see what they mean. You see, right now, our say hello function is pretty generic. Very simple, right? We're just, printing hello. It's kind of useful, but not really. The power of functions, beyond just being able to call this multiple times, because it only lives in one location in memory, is this ability for us to make it dynamic. For example, in these brackets, I can give it what we call parameters. So in here, we give it parameters inside of the bracket. So for example, I can give it name, which is a variable that I just made up. I can call whatever, and I can leave it like that, or I can keep giving it parameters, as many as I want. I can give it 100 if I want.
However you want.
So in this case, let's just say this is an emoji. So these are 2 variables or parameters that I've created. And this single function is able to receive these parameters. What does that mean? It means that we're able to use these variables inside
when you
of this function.
send them.
For example, I can create this as an F string and say hello and add the name. And then finally add the emoji. And because I have these as parameters, I can use them as variables inside of this code block. Now, these parameters allow us
send emojis inside
the function when we call it what we call arguments. And by the way, the confusion between parameters and arguments, people usually say one when they mean the other. It's a little tricky, so hang in there. Arguments are used as the actual values.
The actual values, yeah.
So now in say hello,
parameters are the variables that receive those values.
And then I can give it an emoji. And you see how my editor is giving me the hint.
The hint.
Give it an emoji.
Yeah, an emoji.
Again, something that editors help us do. So let's just give it.
Ooh, nice.
Now these are arguments. These are the actual
values.
Does that
actually work?
And the name of the variables that we use, that we receive.
That's going to be weird,
so
using emojis
when we
in
define the
terminal.
function, and arguments are used when we call the function. Define and call. And by the way, some people also like saying call or invoking the function. Or invoke. So if you ever hear those words, you know what it means.
Call.
So if I run this, I get hello Andre with that smiley face. And this is when functions get really powerful. Because
nice.
we're able to not just make generic functions that always do the same thing, but we can create functions that do things based on what parameters or what arguments we call it with. So that now I can use the say hello function to say hello to my friend Dan and also my friend Emily. And if I click run, we've made our function more extensible. We can use it in multiple ways.
Reusable.
If we're designing a game, well, we've just used this to greet our users. And based on the username, I can use the same function over and over. Again, we're keeping our code dry and clean by doing something like this. How cool is that? All right, let's take a break, and I'll see you in the next video.
Default parameters and keyword arguments.
In the previous videos, I showed you how to define functions with parameters. Now,
what happens when you don't send an argument?
Positional parameters, or we might want to call them positional.
Positional arguments.
Positional arguments because the position matters. Right? If I change our arguments to, let's say, Andre as the second argument, run, you see that I get hello, smiley face, Andre, which maybe is not what we wanted to do. Positional arguments are arguments that require to be in the proper position. So if we define name here first and then emoji second, you have to make sure that the first argument will be the name and the second argument will be the emoji. However, there's something called keyword arguments. Keyword arguments allow us to, well, not worry about the position. What do I mean? Well, I can do something like this. I can say hello.
When you call
give the function, it a keyword and a value. So I'm going to say emoji equals to, let's say, the smiley face.
Just like
and then, comma, name equals to
PLSQL.
baby. Now, if I run this, you'll see that I get hello, baby.
Hello, baby.
Because I was able to use keyword arguments, I tell it explicitly, hey,
come on,
this and name to be this. So positional arguments, these matter, but keyword arguments, it doesn't.
Why am I losing
this is bad practice
video here?
Because you're making the code more complicated than it needs to be. If the definition of the function is to give name and emoji, you should follow that practice and not confuse other developers, then just stick to that name and emoji. So you can still use keyword arguments, but make sure that they are in order, because why wouldn't you just follow what the function tells you? It's the same result, but at least this way, you
be orderly.
And by the way, these keyword arguments can sometimes be confused with what we call default parameters.
I know
it can get really, really confusing, but this is something that will come naturally to you after you practice a little bit. So I'm going to just comment this out and show you how default parameters work. Default parameters allow us to give right in here, as we're defining the function, what we want.
Inside the parameters.
In our case, let's say
default. Oh, perfect.
Is the default name, and the emoji
easy.
This little angry Darth Vader. Well, it doesn't really look like Darth Vader, but
it's an evil emoji
that we're going to use. So what does this do? Well, if I run my program, everything works the same. If I use keyword arguments and run my program, nothing changes.
The same.
Let's make this.
Why did you don't send any
However,
arguments?
Default parameters allow us to do something interesting. For example, if I run another function, say hello, but I forget to give it parameters or arguments in our case, well, if I run this, I get hello, Darth Vader. Because with default parameters,
by default,
if you're not able to get name and emoji because you were called without any arguments, well, in that case, make default Darth Vader and make default emoji, this little emoji. If I use, let's say, just one argument and I click run, then, well, it will fill that name variable, but anything that we don't give it, like emoji, will be predefined. So this is a great way to make sure that your function runs even if it's called the wrong way. So keyword arguments increases the readability of your code because you know exactly how we're calling say hello. And default parameters allow us to keep our functions a little bit more safe because we make sure that when we use a variable, we're going to have it no matter what, regardless of how it is being called. But positional arguments are also useful because it's nice and clean, right? We're following what the function tells us to do, and it's easy to read. So there's pros and cons of using each, but I hope this demonstrates to you some of the ways that you can define functions and also call functions. I'll see you in the next one. Bye-bye.
Okay. Return the next one.
Welcome back. In this video, I want to talk about an important concept, which is return. It's a keyword in Python that we are going to see a lot when working with functions.
Yeah,
so
with functions.
If I, let's say, want to create a function called sum, which, by the way, already exists in Python, but we're going to create our own. And I'm going to say num1 for number 1 and num2. Well, our sum function is going to add num1 plus num2. Nice and simple function.
Well, you will return that.
4 and 5. Guess what's about to happen? I'm going to
nothing.
Run, and nothing happens, which, I mean, might not be surprising to you because we're not printing anything, right? But what if I run print here? Will this change?
Nothing. Because, nothing.
Is that what you expected? And we've seen it before, right? I mean, remember when we had a list, let's say 1, 2, 3, and then we did something like clear on it in our editor. It gave us this little arrow and said none.
None. Doesn't return anything.
List, something like clear changes the actual list and clears everything and empties the list, but it doesn't return a new list. It just modifies the existing list, but instead just returns none to us. Well, functions are just like that. They always have to return something. And when they don't return anything, like there's no return keyword here, it automatically
makes something.
None. So if we don't,
but it doesn't return anything.
Here, it's always going to return nothing.
Come on, why is video going now?
It's going to say as soon as we get to
what happened?
line 2,
come on.
I want you to exit this function. And when you exit this function,
let me fix something a little. I want to check out. It's the okay. Let's see if. Whoa! I lost video completely here. I just rebooted my HDMI splitter. Ah, wait. There we go. There we go. We're back. Okay, but not really. What am I missing here? I'm thinking seriously about buying one of those SN7B's microphones because although the one I already have is great, and I have two, one used to belong to my late wife, but these are condenser microphones, so everything gets recorded here. I am cleaning the signal with software on my side, on the computer, but if I record directly into the microphone, I get a lot of noise from environment and stuff. So that's why I think I just misuse my money there. But I was able, if I'm recording directly into the computer, I can use software to clean the signal. Because you are not listening to a bunch of noise here. So, but anyway, I'm digressing again.
I want you to return whatever.
Oh, wait. I'm not supposed to watch it there. There we go. There we go. Okay.
This expression gives us. If I click run.
Yeah, now you return the value. Yeah, pretty standard.
And this is a good general rule with functions.
Yeah.
Functions can do two things, right? One, it can return something. So at the end of the function, whatever after the function gets run, we return something, either none or some sort of a value, some sort of a data type. Or we can have a function that doesn't return anything, but perhaps modifies something.
Yeah,
so,
modify
for example,
something.
I could print hi, and if I hit run here, I return none because I don't have that return statement.
Yeah, no.
However, my function does something. It modifies the look of this text, right? It prints hi for us. So a function either modifies something in our program or returns something. And this is a topic that is quite advanced that we'll get into later on when we talk about functional programming. But a good rule of thumb with functions is this. A function should do one thing really well, and usually a function should return something. Now, this doesn't mean that any function that maybe does multiple things or any function that doesn't return something is bad, but it's generally good practice to make your code simple and readable to have these two rules. For example, here, if I have print and addition, well, this function is doing multiple.
Well, that now that he mentions it, is actually really useful to do functions that only do one thing or return one single value. If you get caught in the event that you find yourself doing a lot of things, or it's very difficult to apply this rule, this guideline, more likely than not, you need to divide that function into more functions. So probably you are getting a lot of things done on one function, and you're realizing, well, you know what, it's very difficult for me to do one thing here without breaking the other things. Well, maybe you need to create this divide your task into more functions and call them from other functions, because that's another thing you can do. You can call functions inside functions, basically nesting.
It's worrying about
nesting
and it's also worrying about summing. And the definition, this function, is called sum. I mean, if I didn't know or I didn't see this and all I did was run sum, I think having printing hi would be surprising because the name doesn't really describe what it does. I mean, I'm expecting this to be summed. Why is my program saying hi? So we want to make sure that our function does one thing and one thing only really well. Because as we'll see later on, we can combine and run different functions together.
No.
Also, we want to make sure that we return something. Because this way, what we can do is we can actually assign this return value to a variable. For example, I can say total equals to sum 10.
I guess.
And because this function returns something, and when it's done running, is going to have 15 as a value. That's the same thing as what we're doing here. And here's the cool part. Now I can run maybe sum 10 plus total. Now let's go through this one by one.
Yeah.
I define my function. The Python interpreter is going to say, all right, I know what sum is now. You've defined it. I'm going to keep it in memory. It's going to keep going until line 7. And it's going to say, hey, I want a variable total. And I want that total variable equal sum 10, 5. And before we even assign anything to total, Python interpreter is going to say sum. What's sum again? Oh, I remember here. It's in memory. Okay, but sum, I'm going to give it arguments 10 and 5. So it's going to go run that function as soon as we end this closing bracket. It's going to go into the sum. It's going to say, hey, num1 is going to equal 10. Hey, num2 is going to equal 5. Now we go to line 2. And it's going to say, hey, I want you to add 10 plus 5 because I know what these variables are. And then once you're done with that, and this turns into 15, I want you to return. So the Python interpreter, finally, when it's done calling sum, is going to say, hey, assign the value of 15 to the variable total. And then it's going to go to the next line. Hey, I want to print something. What do you want to print? Well, I want to print this. It's going to say, hey, what's sum? I know what sum is. I have it in memory. And then again, it's going to say 10. And then the next argument is going to be total. Hey, what's total? Let me go in memory and find out. Oh, it's 15. So it's like saying 15. And this is the power of functions, right? I'm able to return things.
Well, you didn't run the example, man.
Call them like this. And I can keep running them if I want to. If I want to make this even simpler, I can go sum instead of total will be right here. And look at that. Now I have it all in one line. And if I click run, again, it still works.
25.
Okay,
yeah.
But what if we do something like this? What if I say define sum, and then I'll say define inside of here another function.
Oh, that's weird.
Num1 and num2. And in here, we finally return num1 and num2.
Oh my God.
Let's test this out. What do you think will happen?
Well,
first, let's say total
fail or do nothing.
10 plus 20. And then
it's going to do nothing because
I click run. I get none.
No, nothing. You're not returning anything from sum.
Because here, I'm saying, hey, I want you to define sum. And what are we going to do with the function sum? Well, inside of here, I'm going to define another function. But this return statement is actually not run, right? Because
you need to call another function.
This part, we're defining the function.
And return whatever it returns.
So this returns none. And we've lost the ability to, well, to call this function. So
why would you do that? One
way is to return, right? So at the end here, we have to make sure that the indentation is right. And we're going to return another func. So let's add return and see what happens here. If I click run, all right, I get this function now.
Yeah, you're
going to equal this function that we returned. And it's in memory. Okay, but I'm not getting the result that I want. Right?
No.
And why is that? Because, well, we're not calling this function. So there's a few ways that we can do this. We can either give it the parameters or the arguments in here. So let's say 10, 20, and if I click run, I get 30. Or if we want to keep whatever we give it here, I can just simply say another func. So if we give it num1 and num2, and I click run.
As arguments.
Hey, look at that. I get 30. Now, this video you might have to watch over and over because it does stretch your mind a little bit. And to be honest, this function is not very good because it's very
really.
Your function should be easy to understand. So we might want to change this up a bit.
So
maybe
my question is, if I can do this, why? Is this the preferred way to define functions inside another functions maybe? Or is this a mechanic that was inserted for another purpose? Is this a side thing to maybe creating methods and classes? I don't know.
Over here, of having the same parameter names, just to clarify it, maybe we can say n1 and n2. And then here we do n1 plus n2.
Well, not that I think about it, some excuse will be, you know what? Maybe you need to do this in order to make sure that you're going to be calling functions inside other functions that you don't want to be to have loaded into memory if not necessary. Maybe this is a way. Or maybe if I want to have the code of all my mini functions enclosed into the main function. Let's say, okay, you know what? I realized that this function I writing here is going to benefit from dividing the task into mini functions, and I want those mini functions close together. Maybe that's another excuse I will use to justify this. I don't know.
Clarify that when we return this other function, I'm using the parameters num1 and num2 that we called here. Because this definition of a function doesn't really care what these things are. It only cares when another function gets called. Now, if you need to pause the video and look at this and maybe practice this a little bit, that's completely understandable. But I wanted to show you the power of return. You can have nested functions, just like you could with conditionals. But you have to be careful that your function either returns something, otherwise it's going to return none. And most of the time, you're going to want to return something from a function. So we can do something like this where we assign it to a variable. So we can use it later on in our programs. I'll see you in the next one. Bye-bye. One last thing. A return keyword automatically exits the function. So that in here, if I added another piece of code like print, hello, or maybe even have return 5 in here, you see that it's still valid. But if I run this, I still get 30 because the interpreter never gets to line 5 and 6. Because as soon as we return something from a function, it exits that function. And the reason that this part doesn't exit the function
It's a
is because,
return
remember,
statement.
inside of this
That's the
function,
same
we're defining
here
it.
in
So we're not actually
C,
running this part. We're just saying
Java,
when we see
JavaScript.
another function coming up in our code, we know what it is, but we're not going to run it. So it's going to look like this. And as soon as it sees the return statement, when it gets called, it's going to say, all right, I'm exiting out of this function with this value. Just
one thing you can do, because I see that this is the end of the video, is that you may actually like or want to have several return statements inside the function. How? With if statements. Basically, you can choose, you know what? If certain conditions are met, then return this value. If not, maybe return this other value. So you may have 3, 4, 5 return statements, and you may choose between them using if statements. That's an excuse I will use to have several return statements. I have not done that in any project so far, but I've been doing that for exercises and whatnot, examples. But you may have several return statements inside the same function and choose among them using if statements. Thankfully, my functions are really small, so I don't really need to do something like this.
little heads up.
Exercise, Tesla. I call back to Elon Musk, I say. Okay, and you need to solve a problem for the self-driving car. Oh, that's actually, it reads, okay. It's time. Okay, let's take a screenshot of this because I think this is hilarious. Okay, let's take a screenshot time with my retarded face. Okay, it says, it reads, it's time for a little exercise. You just got employed by Tesla. Oh, thank you. And you need to solve a problem for their self-driving car. Actually, it's funny that he uses this as an example because it's my ambition to work for Tesla on the self-driving car project for and work with AI. Basically, that's my ambition, but I don't know. Maybe it's never going to happen. Who knows? Oh wait, let me just let me take a moment. Oh, come on. Are you serious? There we go. I want to tweet that one. Okay. I spread my ambitions on the internet. Okay, you can find the solution problem here. Okay, thank you. Let's see what can we do here. REPL is taking some time to load today. I wonder why. It's not my computer, I think. Okay, now show me the files, I guess. Okay, let's see this example. And let's paste it here. Okay, now what? Okay, age is an input. If I cast age as an integer, and instead is below 18, sorry, you are too young to drive this car power enough. If age is greater than 18, wait, why not greater than equal? What happens if I am 18 years old? So I don't know. I'm going to make this here. Oh wait, he does have that cover here. Power on, enjoy the ride. And the last elif is when age is exactly 18 years old. Congratulations on your first year of driving. Enjoy the ride. Okay. Number one, wrap the above code in a function called check driver age. Whenever you call this function, you will get prompted for age. Notice the benefit in having check driver age instead of copying and pasting the function every time. Instead of two. Okay, let's do that. I will say that I'm going to basically enclose this in a def. Def, and the name of the function is going to be this. Okay. And I need to fix the indentation of all of this code in order to make it belong to check driver age. And finally, I can just copy paste the call. And that's it. That should work. Check driver age. Oh, wait. I'm missing a semicolon here. Thank you. Okay, I'm going to be 18. But it's not going to work because I need to add. Oh, okay, well, that works, I guess. Oh, yeah, because age is a global parameter. It's a global variable, so I already have it. Okay. I may like to parameterize this one. But let's see that. Okay. Okay, that's the first step, I guess. 2. Instead of using the input, now make the check driver age function accept an argument of age, so that if you enter 92, it returns power and on, enjoy the ride. Also, make it so that the default age is set to 0 if no argument is given. Okay, let's age with the default with 0 if no argument is given. And well, instead of an input, let's try to comment this one out. Instead of an input, I will just use the age. That is here. Okay, so if I do this and I run, sorry, you are too young to drive this car. Okay, what? Oh no, never mind. Again, there we go. Sorry, come on, it's it then. Okay. You are too young to drive this car. Powering off, I guess. Powering off. Okay, so it's working as intended with 0. What happens if I say 92 as here specify? Powering on, enjoy the ride. And if I am 18 years old, congratulations. So that's the parameterized version of the function here. And by the way, I am an advocate for using default values for all of your functions, because most people do this, and that seems to work pretty okay here. But when you don't send a value here, you are going to get an exception. And this happens not just in Python. I already knew this would happen because this is a common issue with programmers in all programming languages. They don't sanitize their function definitions and method definitions. It's a rule of thumb that basically you make, and not just your functions, also your methods. You need to make your functions calls sanitized, which means that if you don't send any values, your entire program is not going to crash. It's not going to crash, just like here, for example. So this is a crash. So to avoid that, give all of your functions sensible default values for all its parameters. So basically just sanitize your calls. And the same goes for classes and objects. Allow your classes to give, when you create an object of your own classes, and you try to call any method for that object that you created, avoid doing this. Crashing is not okay? Because other people may use your classes and your objects, and if they try to use your objects as they came out of the box, like this one here, and it crashes, that just looks awful. So that's my recommendation is to sanitize your arguments, at least for functions and methods and classes and whatnot. Okay, let's continue, I guess. Oh my god. Okay.
Hey, long time no see. It's been a while.
Oh wait. What's the solution then? Yeah, okay. What's the solution then? Run? Where's your A? Well, I really need to just see the files. That's pretty much it. Wait, what? Oh, wait, he's defining another function. Okay, it's pretty much the same thing. But, yeah, I guess. Okay, yeah, why not? Yeah, he defined it down here. So I just modified the version he already gave me. Okay, never mind. It's fine. What's this?
It's been a while, but I'm glad you're back, and I'm glad you're still hanging in there. Trust me, things are gonna get a lot more fun once we actually start building applications, but we do have to go through the basics, so hang in.
Yeah,
now,
those are the basics.
Mentioned methods and functions before, and I briefly touched on the subject. Right? We have functions like list, print. We have things.
Are we touching methods here? Because I would consider methods an advanced subject, especially when we have not created classes or objects. I don't know. I think it's weird to talk about this at this point, but let's see.
Max, min, what else do we have? We have input. These are all built-in functions.
Functions.
Python just comes with this, and we're able to use them. And we also learned about functions that we can create ourselves. Custom functions like, well, some random stuff.
Yeah.
I just created a function that does absolutely nothing. I can just pass through. And these are all functions because the way we call them is, well, we say some random stuff, and then we call it with the brackets and give it some sort of data or leave it empty. But we also learned about methods. And methods were different because the way we used them was using the dot notation. We set dot something. For example, if we had a string, hello, and I do dot, I get a list of all these methods that the string data type can use. These aren't things that we can use like this, because if I do capitalize like this, well, it's going to give me an error. It's going to say, well, I'm going to get an error with Max because it's expecting an argument here. But let's comment this out and click run again. I get capitalize is not defined because it's not a function. It's a method.
It's a method. It belongs to an object. It's owned by an object.
Whatever's to the left of the dot. In our case, the string owns the method capitalize. And that's what methods are. They're built-in objects that have methods such as strings, dictionaries, sets, tuples, all the things we've talked about, where as soon as we do dot, we have access to all these methods. They're owned by an object or a data type. And the fun thing is that there's ways to build your own methods. And I'll show you how to do that later on when we start talking about classes. But you can see here that our editors help us determine what type of methods that we can use. And again, these are built into Python. And you can also learn about these methods that we can use by going to the Python documentation, right? Python 3 documentation is going to have a ton of things for us. If we go to library reference, for example, you can see here that we can learn about built-in types. So let's go to the set types.
Yes.
And here you can see that we have set type, and it shows us how we can use it. Now, these are built into Python. And
I
you can
want
also
to
learn about these methods that we
what
can use
page
by going to the
is
Python
that
documentation,
one?
right? Python 3 documentation
Okay, sure. So he's Googling Python 3 documentation.
is going to have
The website is python.org?
a ton of things.
Docs
Go to library
Python.org.
reference, for example.
Okay. So that's the website. Okay. So maybe it's well, he Googles it, but it's docspython.org. Okay. There we go. So this is the last stable version, 3.10.4. Keep this under your pillow. Library reference, okay. Built-in functions, nice. Oh, there are not many. There is a zip function. What does it do? Is zipping stuff? Oh, okay. So it's not zipping files. Okay, it's going to iterate over several iterables in parallel, producing tuples with an item from each one. Oh, that's interesting. So one sugar, two, whoa. This is really interesting. I can come out with a lot of things to do with databases here. Yeah, why not? Okay, fun. Let's go back.
See here that we can learn about built-in types. So let's go to the set types. And here you can see that we have set type, and it shows us how we can use it. Now, Python doesn't have the easiest documentation to read for beginners, unfortunately. So sometimes it's better to actually just Google instead of going through the actual documentation. But you see here that the set type has clear, has pop, has remove. If we want to use it, we have update, and these are the methods that we can use. But at the end of the day, both methods and functions allow us to take actions, right? To take actions on our data types, to have our programs do something. And although they have these different names and one has a dot in front of it and another one, well, we can just call it like this. The difference is very minimal. But keep that in mind. When you hear people talking about methods and functions, there is that difference. And like I said before, we will get to methods when we talk about classes to show you how we can create our own. I'll see you in the next one. Bye.
Docker strings. Yeah, he mentioned Docker strings before.
There's a unique thing that we can do with functions that we haven't seen before, and they're called doc strings. Let me show you what I mean. If I had a function here, and we'll just call it test, and test, let's say, receives a parameter that is a, and in here, it's going to print a. What a useless, completely useless function. Now, if I run this, well, nothing's going to happen because I have to call test and then say, well, exclamation marks. And you see that our function works. But we can actually, with functions in Python, use something called doc strings. And it looks something like this. You do single quote, single quote, single quote. So 3 of them. And then at the bottom, once again, single quote, single quote, single quote. So at the beginning of the function, like this. And in here, I can add some info about the function. For example, this function tests and prints param a. Now here's the interesting part. If I run test here, and I do brackets, look at that. My editor tells me info. This function tests and prints param a. This is called a doc string. And what it allows us to do is to actually comment inside of our functions in a way that if another person, let's say, is using the test function, they can actually, let's say, in the future, when we write large applications where it's not just 10 lines of code, or maybe we have different files, instead of just finding what test does, as I'm typing it, it's going to tell me, hey, test is going to return or print param a. So I find out information about this. And if we ever use something like length, for example, and run this, you see that this gives us information
Return
about
the number of
items
items in a container. Nice.
Another way to view this, mind you, when we talk about developer environments, our editors are going to do this automatically. But there's a few other ways that we can actually read this. For example, I can do the help function, which we haven't seen before, which comes pre-built with Python. And we don't want to call the function, I just want to call help on test. If I run this, look at that, I get test a info. This function tests and prints param a. So we can use help to find out what a function does, which is really, really useful. One other way to do this is to use what we call a magic method, or a dunder method, which, again, we'll get into later on in the course. I do
what was the name?
Then I do doc.
What the hell?
Which is really, really useful.
Help.
Another way to do this is to use what we call a magic method, or a dunder method, which, again, we'll get into later on in the course. I do double underscore, then I do
underscore,
and then double underscore, like this.
What?
If I click run. Well, we have to print something here. So
okay.
Print.
It's the same thing?
And look at that, I get the same thing. So these doc strings are really, really useful to add comments and definitions to your functions, so that when other people on your, let's say, team or coworkers come across your function that you create, they're able to understand what it does right away without searching.
Without searching for the Python.
Very useful feature.
Oh, nice. That's actually really useful.
I want to talk.
In Java, we do have something similar. You basically write a comment. It's not a string, it's a comment, a multi-line comment on top. And I believe you have to use a decorator there or a keyword, and you run your source code files through the Java dot generator. I don't remember the name, but it's what basically is going to happen is the document generator for Java is going to pick up those comments, and it's going to look for the decorator or the keywords, and then add or build your help file as an HTML file, and it's going to create technical documentation about whatever your code is being defining. But I found it really difficult to use, and I decided that it wasn't worth it to create a web page that I need to host somewhere in order to be of any use at all. And this is way easier to understand because it belongs to the code and is already integrated with the programming language itself. It's not something that I need to do with an external tool. Although in Java, if you already have everything as a comment, you can read it directly there anyway. So the programmer is not going to find himself or herself looking through other sources. But so the comments are really useful anyway.
Quickly about the idea of clean code, something that we've talked about before. And this is a good example to do with something like a function. For example, let's say we had a function that perhaps checks if a number is even or odd. So let's say is odd or even as a function that takes in a number. And we're going to here say, well, how are we going to check? Well, we can use the modulo operator. I can say if number modulo 2, which remember gives us the remainder. And if it's an even number, the remainder is always going to be 0. So this is going to tell us if it's an even number. So if it's an even number, then I want you to return true. And if it's not an even number, so let's say num.
Yeah, you can return.
Doesn't equal 0. What? So if this is an odd number, there's always a remainder. In that case, we return false. So maybe let's change this function to be more descriptive. Is even. So it's going to return true, if it's even, false if it's not even. So in here,
that's not going to run because it's not an elif.
Oh, I got an error because I have to make sure that I do an elif statement here. We have to print here, so let's do print.
Well, that happens to me all the time.
I get true. If I do 51 and click run, I get false. Right? It seems to be working, but how can we clean up this code? Well, here's the thing. We have some ways that we can actually make this a little bit tighter. For example, if we're only checking for is even, we don't need to check this again.
Yeah, it's not. It's unnecessary.
Number modulo 2 doesn't equal 0. That is, if a number divided by 2 doesn't always have a remainder of 0, we always know that that's, well, it's not going to be even. So we don't even need this statement. We can just say else, right?
Just else.
So if I run this, this still works. Sorry, so we cleaned up our code a little bit. But here's the thing. Another thing we could do is we know that return exits the function automatically. So we don't even need the else statement. I can just say return here because it's only going to get to line 5 if the statement is not correct. So if it's not even, well, I'm going to skip line 4 and go to line 5. So that if I run this still works. All right, but we can make this even cleaner, right?
Yeah.
Right now we're just returning true.
You may return the actual expression.
Returning true, false directly. There's usually a better way, and that's using an expression that evaluates to a boolean. What we can actually do is simply say, hey, remove all of this, and I want you to just return.
Return like this.
And if we run this, this still works. And if I do 50, this still works. Because what we're saying here is I want you to return whatever this value is. And this is an expression, right? That's going to evaluate true, false directly.
True or false,
so directly. As we had before, but look how much cleaner that is. That is just nice, simple code. And as a developer, I can come in here and right away see that, all right, is even is just performing this operation and returning true or false. So this is a good way to think about clean code. How can you clean up your code? And mind you, there's no perfect solution. You can always clean
you can always clean code and make it.
Advanced programmers. Hey, I'll see you in the next one.
But before we move on, wait, God damn it. I'm losing video again. Why? Never mind. Well, we are. You can. This is called refactoring, and there is a. I don't remember the name of the books that I read about it. But refactoring is a really good practice to clean code. Basically, it's the practice of rewriting your code to make it more readable without modifying its behavior. That's refactoring, in my opinion. But now we have to be very careful to not refactor so much that the code that is, instead of having clean code, we are getting clever code. And what I call about and clever code sounds good, but it's not readable. So we need to step away, a couple of steps behind that line, and avoid getting into the realm of okay. Well,